So in Chapter 2, Section 5, we're going to prove statements about segments and angles. First, we're going to discuss the way we prove things. We're going to use a two-column proof to do that. A proof is a logical argument that shows that a statement is true. There's various formats for proofs. We've got a flowchart proof, a paragraph proof, and a two-column format. Now, the flowchart proof is interesting because it's very visual. I think I actually like a flowchart proof. A paragraph just lists everything in paragraph form. And while I do think that a flowchart proof might be a great tool for some people, you might see them online. You might want to practice seeing a flowchart proof and transferring it to a two-column proof. But for our class and our purposes, all of our proofs will be two-column format. They are the most popular. And what you have is on your two-column proof, you have this T-chart. And what happens is on the left, you have statements or maybe steps. And on the right, you have reasons or really justifications for what you do on the left. Okay, so what happens is on the left side, on the statement side, you're basically starting with a given statement and you're trying to put statements or steps to get from the given to the fact that they want you to prove. So you start your left side with the givens and you end it with what you're wanting to prove. On the right, for every step you put on the left, you have to have an explanation for each one of those statements or steps on the left. And your explanation can't just be, oh, because, I think it's this way. It has to come from specific things. The next slide is going to talk about valid reasons that you could list in the right side. So notice the valid reasons. Well, first of all, given information is definitely valid reason. So anytime that you list on the left something that was given to you in the problem, either with words or in the diagram, you are going to list that on the right as a given. The second thing you're going to have are definitions. So these definitions must be known, like examples of them, maybe definition of congruent angles. Maybe that's something we're going to see. Okay, maybe definition of a midpoint. Okay, maybe definition of complementary angles. So we've learned a lot of definitions this year. These are just some of them, okay? Properties, again, properties. We've learned lots of properties this year. We talked about properties. For example, multiplication property of equality. Right? We talked about that yesterday. We talked about the reflexive property of equality. We talked about the symmetric property of equality, and so on and so forth. We talked about a ton of properties that we used in algebra, but we also discussed how reflexive, symmetric, transitive can also be used when it comes to segments and angles. Postulates. You've already started learning about a lot of postulates. For example, you learned the segment addition postulate. Okay, that's one very common postulate that you learned. Another postulate that you've learned is angle addition postulate. Okay, these all came in Chapter 1, but you still learn them. Okay, and then the last thing we're going to talk about, and you can use, are, for example, theorems. And we haven't learned any theorems yet, okay? But we will learn them, and as soon as we start to learn our theorems, then we can use them as well, okay? One interesting thing is that every single one of these acceptable reasons and proofs is going to come from something we've already covered in the book. So something we have covered in the book. So there is no definition or property or postulate or theorem that we are expecting you to know from previous years of mathematics, something you learned in middle school or something you learned in Algebra 1. Every single thing that we're looking for, every explanation, every property, every postulate, we're teaching you. And so right now, the proofs that you do, we're in Chapter 2. So all of these things, right, that we're doing right now has to come from Chapter 1 and Chapter 2. Okay, once we move on to chapter 5, then every single one of the definitions, properties, postulates, and theorems have to come from any chapter prior to and including chapter 5 or whatever. So we're never going to go ahead either. So right now you can't pull in a postulate or something from chapter 7 because we haven't covered it yet. We expect you to use the definitions, properties, postulates, and theorems that you've learned at this moment and from the beginning of the school year, okay? That means you have to stay current. So you have to stay current, okay, on all these definitions and postulates, all these things that you've learned. You can't just forget them, okay? You have to remember them. If you learned it in chapter 1, section 2, you have to remember it. So make yourself a list or something you can study from and keep it going. Keep adding to these as you go and keep refreshing your memory. Now, we talked about theorems in the last slide, yet we haven't really defined a theorem. And a theorem is basically a statement that can be proven, and it's proven using deductive reasoning. Now, once we learn a theorem in the class, we're going to use the theorem to justify our statements, right? So sometimes people get postulates and theorems confused, okay? Both of them, once we introduce them and go over them, you're going to take them as facts, and you're going to use them to explain things. The difference between them is postulates really come from, a lot of them are from inductive reasoning, and they are just blatantly obvious. They are obvious and don't have to be proven, okay? We talked about this before. No need to prove them, okay? They're just so obvious. Like the angle addition postulate that says that, if an angle has a ray that intersects it, then the little angles that are formed add up to the big angle, or the segment addition postulate, that all the pieces of a segment add up to the whole. It's so obvious, there's no need to prove it, okay? Theorems are things that are not that obvious. We have some theorems that say, for example, vertical angles theorem, that vertical angles are equal. Well, that's not obvious. We have to kind of learn that. We have interior sum of a triangle theorem that says that the three angles of a triangle add up to 180 degrees. That's not obvious. And so these need to be proven. And once we prove them over and over and over again, then we don't have to prove them anymore, and we take them as a fact, okay? But they're just not obvious, okay? We have to use more facts and reasoning and deductive reasoning to get to the conclusion that, okay, this theorem, this thing is true, now I'm going to make it a theorem. So the first two theorems that we're going to cover are properties of segment congruence and properties of angle congruence. And what we're saying is that segment congruence can be applied to the following properties: reflexive property, symmetric property, and transitive property. In other words, those properties work to prove that segments are congruent, and they also work to prove angles are congruent. So when I come to this slide, you're going to remember this from yesterday. Yesterday we had a chart that looked very similar to this. Now this one is the property of congruence as opposed to properties of equality. Yesterday's chart, right? Yesterday's chart had something like, it was DE, segment DE equals segment DE, and we had something like angle D equals angle D. That went with the reflexive property of equality, where basically we're saying that the segment length is the same, it equals itself. So in this one, notice that we're saying congruent, right? We're using congruence instead of equal sign. So we use congruency or congruence when the numeric value is not relevant, okay? So in other words, when the numeric value is not relevant, we don't need to know the numeric value, we'll say that two segments are congruent. We just want to know they're the same size, but we don't care that what that size is. Same thing with angles, okay? We use congruence when we want to say that the angles are the same, okay? Angles are the same size. Again, we don't need to know, and we don't really care what the size is. We don't need to know that it's 105 degrees or 65 degrees or whatever. So we use equality, right? We use equality when the numeric value and this is, I know this is a little messy, but when the numeric value matters. Okay, so when I want to talk about angles and, you know, they add up to 180 or something like that, and all of a sudden the number matters, I'm going to use the equal sign and the properties of equality. But when I don't really care about the actual numeric value, then I'm going to use congruence. Now, for our first several proofs for this chapter, we're not going to be picky on whether or not you're going to use, property of equality or congruence. You can use them interchangeably, and we're not going to give you a hard time. Eventually, we'll get a little pickier on it, but we'll walk you through that step. But if you can try to do it the right way, which is really, again, if size doesn't matter, the degree measure doesn't matter, we use congruence. If the number matters, use equality. And now we're going to get to our first proof. And we have a 2-column proof. And you're going to notice that what we did was we gave you a given statement. The given statement says that AC equals AB plus AB. So what they're saying, and you always want to look at the diagram and see what they're telling you. They're telling you that AC, the entire segment AC, is equal to AB, which is just this piece, plus AB. So if you double AB, you get the entire segment. And they want you to prove that AB equals BC. Okay, so we got to try to figure out how can we prove that, right? So let's look at the proof that's given. The first several proofs that you're going to be doing in this class, you're going to have the statements given to you. And what you have to do is come up with the reasons for those statements. What enabled those statements to be made, right? What are the justifications for them? So the first statement, if you notice, it says AC equals AB plus AB. Well, that was given to us. And so remember, the first one is always the given. And don't give away these free points because, even if you don't know how to do anything else, remember given, that's a freebie. In number 2, notice that they said AB plus BC equals AC. And so we have to look at that and say, well, how did that come? Did it come from statement 1? Like, was something added or subtracted or reflexive property applied that took you from 1 to 2? And I can't find anything that I did to 1 to get to 2. There's no addition or subtraction or multiplication or division or simplifying. Nothing made that happen. So then let me actually look at statement 2. Statement 2 says that AB plus BC equals AC. So what it's saying is the parts add up to the whole. Well, this is actually a postulate. This is the segment addition postulate that we learned about in chapter 1. So segment addition postulate, or SAP for short, says that the pieces add up to the whole. And so they brought this in. Now you might wonder, why did they bring this in? Well, notice that by bringing this in, notice that they want you to prove that AB equals BC. And if you notice, AB has already been introduced into this problem, but BC had not been introduced yet. And by bringing in the segment addition postulate, they were able to introduce BC into your statements. If we have to end up with AB and BC at the end, you want to bring BC into your statement side. Okay, so now that we have these two statements, so far we know what we know. We have 1 and 2. Now we look at 3 and we see, okay, AB plus AB equals AB plus BC. So again, I'm going to look at the one on top, and I see that I have AB plus BC, and I still have that at the bottom. Now, I'm not a super big fan that they switched the side on the equal sign, because that's really like a symmetric thing that they did there. But at the end of the day, that's not, what they did, the big picture of what they did here, but they should have kept it on the same side. What's different is notice that originally AB plus BC equaled AC, and now it equals AB plus AB. So they basically substituted AB plus AB for AC. They swapped them out. And so we say, well, is that something that they can do? Well, remember, if you use substitution, somewhere in your statements above the time when you do the substitution, you have to show that those things are equal. And notice that here in this step, they showed you that AC was equal to AB plus AB. So at any point after I say this, I can sub one in for the other. So yes, I can substitute AB plus AB for AC. And so this step here was substitution. And it's the property of equality that we've talked about. So now I've substituted. So now we look at what we're left with, and remember what we're trying to prove. We're marching along here. We're trying to prove or be left with the fact that AB equals BC. And so how did they get from here to here? Well, AB and AB, BC and BC. And notice what happened was the ABs were canceled out. Well, what property says that I can cancel them out? What was done to cancel them? And if you notice, what was done is minus AB. They basically subtract AB from both sides, and it canceled it. And so the step that happened to get to 4 was the subtraction property of equality. And so now we have justified the 4 steps here. Okay, now I probably would have done this a little differently, like I told you. I would have had step 1 again be AC equals AB plus AB, no problem there. Step 2, I would have kept AC probably on the left, and I would have said AC equals AB plus BC. That still would have been segment addition postulate. This still would have been the given, okay? Now that I have AC on the left, now I would have subbed AB plus AB in for that, equals AB plus BC. That would have been substitution, which would have been valid. And then again, I would have done subtraction, and I would have subtracted out the ABs, and I would have had AB equals BC, and I would have used subtraction. So the only thing I really would have done differently, these are all properties of equality, is I would have not switched sides here. I would have left that on the same side, okay? But again, it's still correct the way they did it. Now, the second proof that you're going to do, again, is another one where you're given it's a segment. You're given a segment. If you look over on the right, you kind of analyze it. You have line segment AB, and you have M, which is in between A and B. In the given statement, it tells you that M is the midpoint of AB. So as soon as you know that M is the midpoint, I sort of go to my drawing and I start writing what I know. And I know that if M is the midpoint, I know that those two parts, or those two segment pieces are going to be the same. I also know that, AM plus MB is going to equal AB. And so I feel like this is going to come into play in my proof. Now, notice they asked you to prove 2 things. We never ask you to prove 2 things, okay? We'll ask you to prove 1 thing only. So even though there's 2 things here, we're only going to ask you to prove 1 thing at a time, okay? But let's follow the proof that they did, and let's see what reasons they gave. So first, or what reasons we need to give. So step 1, they said M is the midpoint of AB. Well, they said it because that's the given information, and it's super important. Step 2, they tell you that AM is congruent to MB. So remember how I told you over here, AM is congruent to MB. Well, as soon as they told me that M was the midpoint, I knew that those 2 pieces are congruent. How did I know that, and how did you know it? Because I'm sure you knew it as well. Because we learned in chapter 1, we learned the definition of a midpoint. We learned that if M is between A and B, and if M is the midpoint, we learned that the length of AM would be equivalent to the length of MB. In other words, segment AM is equal to segment MB. So definition of a midpoint tells you that the 2 segments are congruent. Now notice from 2 to 3, it's the same thing. It's still AM, it's still MB, but what changed is we went from congruence to equality. And this is a step that you're not going to have to do for us. This is what we were talking about. But all this is saying is that if these 2 segments are congruent, then in 3, we can conclude that they're equal, that their numeric value is equal. And we know that because, again, in chapter 1, we learned the definition of congruent segments. And we learned that when things are congruent, they are the same size. So they have an equal length or an equal degrees, equal size and shape, but that means their lengths are equal. okay? So anytime you are going to go from congruent to equal or back from equal to congruent, you can use definition of a congruent segment or angle to do that, okay? In number 4, we look at the next step and we say, okay, they went from here to here. Well, what did they do? If I'm looking at the picture, I can't really see any relationship between 3 and 4, like that they added something to both sides or anything like that. So maybe I need to look at the picture. I'm going to go back to the diagram. It says AM plus MB equals AB. So this piece plus this piece equals the whole. And so the two parts add up to the whole. Well, we know, again, just from using it, that that's the segment addition postulate. And again, SAP for short. Okay, so they use the segment addition postulate. And we just keep kind of walking through the proof, trying to see what happens from one step to the next. So now the next one, from 4 to 5, we notice that we have the same AM, we have the same AB, and the only thing that changed was MB switched to AM. So it was like a substitution. AM was substituted in for MB. And you ask yourself, can substitution happen there? Is that a valid step, right? I know that's what they did, right? But you want to make sure that it's valid when you do it on your own. And anytime that I want to substitute something, I have to make sure that somewhere in the proof I stated, or you stated, that those values were equal to each other, and they did. And in step 3, they said AM equals MB. Once they say they're equal, then we can substitute anytime moving forward after that. We only have to say it once, okay? So substitution was a valid a step here. So then we go to number 6, which is the first thing they wanted us to prove, that 2 times AM equals AB. So again, how did they get from AM plus AM equals AB? Well, if I actually do the addition on the left, 1 AM plus 1 AM is 2 AM. 2 AM equals AB. What they did was simplify. Now somebody mentioned, didn't they do the addition property of equality? Well, no, because addition property of equality says you have to do the same thing to both sides. So I would have to add to both sides. When you're only adding on one side, or you're only subtracting on one side, or you're only multiplying or dividing on one side, what it actually is just simplify. All you're doing is simplifying your side, okay? And then in number 7, you look, and again, you're like, well, what was done to 6 to get to 7? And this gives it away right here. They multiplied both sides by a half, okay? And so it was the multiplication property of equality, okay? Because they did it to both sides. Now, personally, I would have used division. But again, that's why proofs are all different. I would have, from here, I would have divided both sides by 2, and I would have had AM equals AB divided by 2, and it would have been the division property of equality. But they used multiplication, so that's what we're going to use ourselves. So again, notice that every single one of these definitions, postulates, all came from chapter 1, and then these properties of equality and simplification and multiplication property of equality came from chapter 2. We will not ask you anything to prove anything using definitions, facts, theorems, postulates that did not come from the present chapter we're on or the chapters that came before it. And everything comes from your book that we started in chapter 1. And then lastly, here's a summary. So all we're really doing here is we're just looking at, it's summarizing. In a proof, you make one statement at a time until you reach the conclusion. Because you make statements based on facts, you're using deductive reasoning. Usually the first statement and reason pair with the given information. So one statement per line, and then you have a justification for it. Always start with your given, okay? Always end with what you're wanting to prove. So the given is step 1, and the proof, or what you want to prove, is your last step, okay? And then again, the number of steps or statements will vary. Some things will take 12 steps, some things will take 3, okay? And here, you always want to give a last reason for the last statement. And lastly, these are the things that you can use: definitions, postulates, proven theorems that allow you to state the corresponding statement. This is what allows you to say that. The definition of congruent angles is what allows you to say that measure of angle 1 is equal to measure of angle 2, okay? Diagrams matter. So again, you always look at this, what's given, and you look at a diagram if it's given to you. You will be right now a little bit overwhelmed, I'm sure, with these proofs. You're kind of not going to know what's coming, where they're coming from and whatever, but I promise you, you will get better and better and better at it. All of the proofs we first give you will start out where we're going to give you this left column, okay? And then you have to fill in everything on the right. Eventually, as we go, what we start doing is we start giving you pieces. We'll start, for example, we'll give you this one, this, and this, for example. And then you have to fill in the left and the right side. And as we go, we start taking away the things we give you and leaving more things to your discretion until we start to allow you to do the whole proof. But we'll ease you into that, okay? Some of you will get proofs fairly quickly. It'll make sense quicker. Others will take a little longer, but you'll all get there, okay? Don't get discouraged. Just keep practicing. And again, if I can recommend anything, it's to do the work, recognize the common ones that you see in the patterns, and also memorize all those definitions, postulates, theorems that we've talked about, okay? Make yourself a list of definitions, postulates, theorems, whatever, everything that we've taught you up until now. Make sure that you are keeping a list of them and you can refer back to them so that you can commit them to memory every single time you use them. You're going to be better at it.